begin the special lecture number 4, Korean Private Enterprise session. This session is opened for the Korean civil engineering companies, named Daelim Industrial Corporation Limited, Hyundai, E&C Co., Hesom Jotech Co. Limited, for their great contribution in design, construction, and monitoring of social infrastructures by using innovative technology and their great financial support for this conference in Seoul, Korea. So now Professor Shin can speak about each one of these companies.
Hello, good afternoon. See that if you look at the other brochure you have here, one is that is called Sponsors and Exhibition Companies Profile, and I think about 61 companies, and they donated and supported financially. So this is a kind of recognition of those the high-rated company. And the first company of this presentation, and Daelim Industry. Daelim established in 1939. I think Daelim Industry Company has a great reputation to design and construction long-span suspension bridges. One bridge is called the Seohae Grand Bridge, which has been awarded, I think, Year of Structures by the American Society of Civil Engineers several years ago. I think Daelim were presented about experience of Daelim Industry in civil engineering. The speaker of this session were made by the Dr. Song-Jin Hong. I want to invite Dr. Hong on the floor.
Good afternoon. My name is Song-Jin Hong, Civil Business Division, Daelim Industrial. It is an honor to give a presentation at 90th ICS MGE, and thanks to the commit of 90th ICS MGE. This presentation will be given as follows. Firstly, I will introduce Daelim's group and Daelim Industrial shortly, and then the track record of Daelim in civil engineering will be introduced. Lastly, main project of bridge in the view of geotechnical engineering will be presented. Let's watch an introduction video for Daelim Group. Next is introduction for Darim Industrial, which is the parent company of Darim. Darim Industrial consists of E&C unit and the petrochemical unit. E&C unit has three business divisions: plant, civil, building and housing. Civil business division has the best construction technology and construction experience for bridge and dam in Korea. And now we are aiming to become a lead developer based on SOC projects such as hydropower project and water treatment and supply project. Today, I will introduce the construction experience of Darim and construction cases for geotechnical work in bridge project. Let me introduce Darim's experience in civil engineering. First, hydropower and dam. Darim has the best construction techniques and experience in dam. And now, based on these techniques and experience, we are developing the overseas hydropower project, such as Gulpru in Pakistan and Upper Trishuli in Nepal. Marine works. Darim also has a strong point at the marine works, such as port and breakwater. And now, based on these techniques and experience, we are challenging other marine projects, such as offshore wind power. Environmental project. Darim has made great effort to develop water treatment technology. Combining with our advanced river restoration techniques, the water treatment and supply project will become an important part of Darim's SOC business. Let me introduce Darim's track record of bridge project, the main issue of this presentation. Darim has the best construction techniques in the cable-supported bridge, which is the fruit of the most advanced bridge technology. Starting from Dolsan Bridge in 1980s, Darim has carried out many cable-supported bridge projects. And by successfully constructing Isun-shin Bridge, Darim becomes the sixth construction company in the world and the first in Korea to have its own cable-supported bridge technology. After Isun-shin Bridge project, based on our advanced technology in cable-supported bridge, Darim has been carrying out the challenging bridge project, such as Saechonyeong Bridge, multi-span, multi-pylon bridge, and Dandong Bridge is a single pylon and single span suspension bridge. Also, we are now ongoing overseas landmark bridge project, such as Sungai Bridge and Temburong Bridge in Brunei, and Çanakkale Bridge in Turkey, which will be the longest suspension bridge in the world. Darim also has a lot of construction experience and advanced construction techniques in arch bridge and extra gauge bridge, as well as cable-supported bridge. Let me introduce Darim's main bridge project and the construction cases for geotechnical work. Seohae Bridge is a meaningful bridge to Darim. Darim could develop our own construction techniques for the cable-supported bridge by performing this project. This is the foundation work of Seohae Bridge. The sea level changing and the velocity of current are very high in this area, so we decided to construct the foundation using copper dam method. The circular cell, which is 25-meter diameter and made up of sheet pile, are embedded at the location of the foundation. By land filling the inside of these cells, the copper dam for foundation was constructed. We are applying shallow foundation because bedrock was a relatively shallow depth. Retaining wall was constructed inside the copper dam to construct the shallow foundation. The last picture is the aerial view of the copper dam and the shallow foundation. The size of the copper dam was 99 meters by 175 meters. Isun-shin Bridge is fourth longest suspension bridge in the world and the longest bridge in Korea. Darim could establish our own construction techniques for the cable-supported bridge by performing this project. In Isujin Bridge, we applied drill shaft for the foundation of bridge because deep soft ground exists under the seabed. Drill shaft was constructed by landwork using the ship collision protection. The soft ground under the seabed was improved by SCP and DCM method. And then ship collision protection block was constructed to landfill by inside reclamation. The diameter of drill shaft are 3 meters, and the length of drill shaft for pylon 1 and pylon 2 are 43 meters and 33 meters, respectively. The pile cap size of the pylon was 31 meters by 72 meters. Isujin Bridge has 2 different types of anchorage. The anchorage number 2, constructed in offshore area, is a gravity anchorage. Diaphragm wall with the diameter of 71 meters and 35 meters high was constructed filling with RCC. On the other hand, the anchorage number 1, which is constructed in onshore area, applied on also anchorage because the bedrock was found at a shallow level. The also anchorage resists cable force by strength of bedrock, hence we could reduce the construction cost by 1/3 compared to the gravity anchorage. Secheonyeon Bridge, which is 3 pylon 4-span suspension bridge, represents DERIM's advanced technology for the cable-supported bridge. Secheonyeon Bridge is located in a weak sediment layer and deep water level. One of the distinct characteristics of Secheonyeon Bridge is an anchorage installed in offshore area. The anchorage, which is a combination of drill shaft and caisson, resists the tensile force of cable by its own weight and resistance of fire. The inclined drill shaft was installed to increase the lateral resistance of anchorage. The size of this anchorage caisson is 21 meters by 31 meters and 90 meters height. 12 drill shafts with the diameter of 3 meters was installed. The last picture is the anchorage constructing in offshore area. As you can see, anchorage and the pier of the approach bridge is combined. DERIM Civil Business Division has world-class technology in bridge, dam, marine works, and water treatment and supply project. DERIM, the global developer representing Korea, will give you the best solution. Thank you.
So I'll move to the next presentation. Hyundai Engineering and Construction Company, established in 1947. As you know, Hyundai is famous for the automobile, but many people don't know that this great conglomerate was initiated by the construction company. Hyundai Construction Company has been working many projects in domestic and overseas, including bridge construction in Kuwait recently, and also land reclamation work in Hong Kong and Singapore, and now in the nuclear power plant in the United Arab Emirates. I think the title of this session is Hyundai Engineering and Construction Dredging and Reclamation Project, will be presented by the Dr. Won-ho Chung. Okay, floor is yours.
Good afternoon, ladies and gentlemen. My name is Won-ho Chung, and I'm working for Hyundai as a general manager and geotechnical engineering team leader. I take this opportunity to introduce who Hyundai is and share some marine project related geotechnical works. I have divided my talk into two parts. First, the introduction of Hyundai E&C, then the brief of major marine project which we have successfully completed at Middle East, Asia, and Korea. I'm going to start with the company key figures as shown on the screen. Hyundai established in 1947, and we are #1 company in Korean construction industry. Recently, Hyundai has ranked #1 in the construction and engineering industry section of the Dow Jones Sustainability Index for 5 consecutive years. You may have seen articles about this. We are also 14th largest global contractor evaluated by ENR report in 2016. This is main structure of our company. We have 4 operating units named Infra and Environmental Division, Building Division, Plant Division, and Power and Energy Division. Infra and Environmental Division covers all of civil works. This is the details organization chart of Infra and Environmental Division, who is executing all civil works. We have more 900 engineers. This is Hyundai Motor Group's affiliates. So we belong to Hyundai Motor Group since 2011. This graph shows our company's financial status. Our annual sales is about $16 billion and the new order is about $19 billion in 2016. This figure shows our global experience. We have executed 821 projects in 59 nations since 1965. As you can see, our major markets are Middle East and Asia. This slide presents ongoing civil projects around the world. We are running 19 overseas projects in 10 nations and 79 domestic projects. From now on, I'll briefly summarize the points of our marine experience. Except for marine works, we have also remarkable achievements in bridge, tunnel, including storage cavern, expressway, rail and railway, water and environment, and so on. However, due to time limit, only marine works will be presented today. So it will be very generic. So you don't get detailed technical information and construction method. I beg you to understand my position. This is Bubiyan Seaport Project Phase 1 in Kuwait. We completed in 2014. The works consist of dredging and reclamation works, including ground improvement by PBD, DSM, and deep compaction, and piling for large diameter steel tubular pile and sheet piles to form combi wall for main quay wall. This is Pasir Panjang Container Terminal, Phase 3 and 4 in Singapore. Total 150 casings were installed to build 5.6 kilometer quay wall. I was the design manager of this project for initial 2 years. This is another marine works, Colombo Port expansion in Sri Lanka. This work scope also breakwater, dredging, and concrete works. Dredging was executed for port basin and access channels. This is Jebel Ali New Container Terminal, Stage 1 in UAE. So this terminal also, we did reclamation works and also land development works and some board pile works. This is Qatar Economic Zone 3 new port project. The main work scope was dredging, excavation, and reclamation works. Block type fuel was built as a fuel. Also, copper dam and dewatering works involved to provide land-based excavation works. The left figure shows Kwaichung Container Terminal number 9 in Hong Kong. This project, including 2 kilometers of pile deck, quay wall, and dredging and reclamation works with ground improvement works. Right figure is Khalifa Port and Industrial Zone in UAE. This project is similar to Jebel Ali. We constructed 4 kilometers of block type quay wall. Left is Pulau Tekong reclamation project in Singapore. This project is the Hyundai first project in Singapore. After this, Singapore became our major market for civil works. Currently, we are running 9 civil projects in Singapore. Right is Jurong Island Phase 4 and Tuas extensions. As you see, the reclamation is we carried out the huge amount of reclamation works by using CSD, TSHD, grab dredger, and hopper barge. From this page, I'm going to introduce several domestic mega projects. The first one is, left one is Sosan reclamation. Sosan reclamation was extensive reclamation project, and finally we got 15,000 hectare land. As you see, we have used abandoned oil tanker to complete the dike closure under severe marine conditions. Right one is Semangam reclamation, also involved extensive reclamation works, and 33 kilometers seawall, which is the longest one in the world. The reclamation area is about 2/3 of Seoul, 400 square kilometers. Last page shows another container terminal and industrial complex development project, including similar work scope to other projects presented before. So I'm going to level my present here. Thank you for your attention and patience.
Thank you. I appreciate. The last speaker of this session, and the company name is Hisong Geotech Company, which has a great recognized as a soil and ground investigation in Korea, and also they has some project in the seismic monitoring work. I think the paper will be presented by the Young-do Park. Please.
Okay. My name is Young-do Park, and I work for Hisong Geotech. First of all, I'd like to thank the organizing committee for giving us the opportunity to introduce our company before renowned guests and participants for this meeting. Next, please. The content of this presentation is history and organization of our company, our representative performances in geotechnical business area, the technology of dam electrical resistivity monitoring, an earthquake early warning system, and maintenance of seismic stations in Korea. Next, please. Okay, now I'm going to present the history and organization. And Dr. Ki-seok Kim founded Hisong Geotech in 1996. There are two business divisions in our company. First one is Geotechnical Division, which carries out geotechnical investigations, including drilling, geophysical survey, in situ tests for civil structures, for example, dams and tunnels. And Seismic Engineering Divisions carry out sales, installation, maintenance of seismometers, and development of seismic software. We also have a research division which carries out government-funded research and in-house research. We have about, say, 65 workers, and the previous two companies, Darim and Hyundai, are our clients. Next, please. I'm going to present the representative geotechnical work performed by us. Next, please. This picture is bird's eye view of Incheon Bridge. I think some of you may have already passed the Incheon Bridge, since this is the main route connecting Incheon International Airport to Seoul. Incheon Bridge is the longest bridge in Korea, and it's one of the longest cable stayed bridge in the world. We participated in the design stage of Incheon Bridge, and our role was geotechnical investigation. Next. This photo shows a total of 6 jack-up barges for drilling in the ocean. We conducted geotechnical investigations from 2004 and 2005. We also had one winter season during the time period. The number of boreholes were 250 boreholes, but there was no single event of accident. So we are so proud of this. Next, please. I will introduce our electrical resistivity monitoring technology, especially applied to earth dams. Next, please. Electrical resistivity monitoring is the electrical resistivity survey over a period of time. For earth dams and embankments, if leakage due to piping occurs, these subtle changes at the initial stage can be noticed. This is because the changes in water content in the pore spaces of earth dam will result in the changes in resistivity values of dam material. So electrical resistivity survey has widely been used over the world. So, and we have fully automated the steps of data collection and interpretation with our newly development system. So we don't have to visit our site to collect the data. Next, please. This figure shows configuration of electrical monitoring system we developed. It's consisting of field systems, which measures transfers and saves electrical resistivity. It also has office system, which does controlling the field system. When several of these field systems and office systems are installed for dams, these can be combined or integrated through web-based system. Next, please. We acquired 4 domestic patents and 1 new technology certificate with this system. Next, please. And these are the photos of measurement equipment in the field system. The equipment automatically sends electrical current into ground, conduct reverse analysis of measured data, and transfer low and analyze data to the office system. Next please. On the left is the result of SuperSting, which is very famous equipment and also a kind of standard electrical resistivity instrument. On the right is the result of our system. As you can see, the two results are very similar, almost identical. This demonstrates the accuracy of our equipment. Next, please. Now our systems are installed at 13 dam sites, dam or reservoir sites. There are a total of about 17,000 dams and reservoirs in Korea. 2/3 of dams and reservoirs were constructed more than 50 years ago. And recently, the issue of aging of dams are more and more important in Korea because several old dams and reservoirs were collapsed. Next, please. I will introduce the earthquake early warning system related to business field of our seismic engineering division. Next. The definition of EEWS, or earthquake early warning system, is very simple. Warning is issued through EEWS before earthquake waves arrives at cities. This is to prevent major damages by earthquake. The scientific basis of EEWS is that the damage-causing S wave propagates slower than P waves. So we can use P waves to stop facilities such as gas pipe or electricity. Next, please. KMA, Korean Meteorological Administration, runs early warning system, and they have 154 seismic stations for this purpose. We have been able to install high-quality seismic equipment for the early warning network. Next, please. And two high-speed railways are operating in Korea. One is to Busan, and the other is called Honam Line. We are able to carry out the project of installation of seismometers at Gyeongbu Line in 2015. Next. Next is about our maintenance of seismic stations. Next. We have installed 592 seismic stations from 1998 up until now. As you see, we have constructed most of public seismic stations in Korea. Next, please. In 2017, we are maintaining a total of 461 stations. I'd like to say almost all public seismic stations are maintained by us. I believe this is because we have trustworthy technology in this field. Next, please. This image includes our company logo and our goals. What it says, the large font at the magnifier, what it says in Korean is, for safety of civil structures, we always try to look into things which are unobvious and even uncertain. Thank you for your attention, and I do sincerely hope your stay in Korea would be a pleasant and enjoyable experience. Thank you.
Thank you very much.